Thank you, Steve. Away we go.
Oh, all
Just,
right
just
then.
Just to
Let
say
me.
one thing, Steve. Sorry to interrupt there.
Yeah.
Just important to say that we in the initial training block that we do for compositing, like certainly the first delve into like Comp 101, which is kind of with a project called Take One Painting.
Mhm.
We use we use your book as the theory book, so we call it the Bible, and
Oh, gosh, thank you.
so all of the first years,
Uh-huh.
you know, we do the sessions and we have that as the sort of background reading. So very good. So just to tell you that.
Well, thank you.
Thank you.
Very good. Appreciate that. And everybody got the fourth edition? Because there's huge rewrite in the fourth edition. I
Oh,
threw out
yeah.
all the film stuff is out, all the NTSC television stuff is out. In our digital cinema cameras, in is ACES, in is light field film recording, and I added a whole bunch of workflow, how to do grain management, how to do lens distortion management, you know, and step-by-step stuff. Because that, you know, you're sitting. This is what people, when they're learning, it's one thing to learn nuke or compositing, but it's another to learn technique. Okay, I tell my students there's three bodies of knowledge. Three. One is your tools, that's nuke. Which button to push to make it brighter? Two, technique, how to approach a problem and solve it. And that's unrelated to the tools. Okay, it's a separate body of knowledge. And third is art. We are artists, people. Okay. So we have to have an artistic sense for what we're doing, and hopefully some artistic training. Okay. So at any rate, that's my spiel to the kids. All right, are we turned over to me?
Away you go. We're all ears.
All right then. Let's see. Let me punch up this. What I did here was I put together a list of what we were supposed to be doing today. Today's topics are, of course, the wonderfulness of me, keying techniques, despill, and working in linear, and premultiply, unpremultiply. Okay, all fascinating topics. So I'm gonna try to hit those. I'll keep the me part short. So a little bit about myself. I actually started in entertaining people with pixels back at Atari in the 70s. Okay. So I worked at Atari for about 6 years, and was in charge of video game development. And that's how I actually got to Hollywood, which got me into the movie industry. Was the video game industry, you know, kind of nosed over in in 83 or so, 1983. So I was given an offer, vice president of game development for Sega Paramount. Sega was a big arcade game, still is actually, big arcade, Paramount Films. The idea was to merge the two, movie studio plus arcade games. You remember that Laserdisc game, Dragon Warrior or Dungeon? It was a guy that fought a dragon. Okay, that kind of kicked off the whole Laserdisc property arcade game thing. So the idea is we're going to work on that. Well, I only was there a few months, and the industry kept tanking, and they canceled the project. So I found myself on the streets in Hollywood, unemployed. Well, a buddy of mine worked at Robert Abel and Associates. Now, Robert Abel, y'all are too young, bunch of young whippersnappers here. Ian will know Robert Abel, right, Ian? Right. And of course, John.
Yes, I know, Robert.
Right-ho. We senior industry veterans. Robert Abel was one of the founders of visual effects. We actually had a software department. This is in the days when you wrote the software to do the CGI. We had a programming department of 25 engineers. And when Robert Abel finally folded, those guys went on to form Wavefront. Wavefront became, was it Maya? No, Wavefront became something else, and then Maya. Autodesk.
Was it Alias?
Alias, yes. Alias Wavefront. Alias
Yeah.
Wavefront, which became Maya. And
Which
Autodesk
then became Maya, yeah.
and it is now Maya. So from Robert Abel came all of this. So after he folded, I formed my own studio in Hollywood for 7 years. And we were doing the usual CG stuff for commercials, okay? We're now talking about in the early 90s, okay? And getting a D1 tape and putting that commercial on an exabyte tape was like, whoa. And we used an abacus. Anybody here even know what an abacus is besides John? It was the first video recorder, digital recorder. You actually could digitize frames onto an abacus and read them off like files. You could now get computers to work on things, okay? So this was, huge stuff back in 1990. John's going, yeah, he was there. So we were working on commercials, and I noticed that the nice customer would take the CGI. We'd render the CGI for the spot and then an alpha channel, put it on 2 D1 tapes, right? They would take those tapes to the post house and use the keyers and switchers in a post house to do the composite over the live action. I said, no, we have to deliver a finished shot. We have to composite the shot for them. Up until this time, all I had ever done was 3D. Okay. So I looked around, nothing. There's nothing. This is before After Effects. There was nothing that could put 2 pictures together. Okay. So turns out there was this little known black box called a Pixar computer. Now, y'all know who Pixar is. Y'all may not know that Lucas had Alvy Ray Smith. He had a team of 3 guys that he chartered. He said, here's a bunch of money. You guys figure out how to use computers to do filmmaking. And they came up with 3 projects. They came up with Skywalker Sound, our first digital sound for movies. Then Edit Droid they developed, which was the foundation for nonlinear editing. That's where you guys don't even know this stuff. When you used to edit, you would take all your videotapes and put them in a dozen machines, right? And then you would sit at a switcher. Okay, call up tape 7, time code, boop, and you would lay down a thing. And then we go to tape 17, and this time code, and lay that down. And it was this whole tedious linear editing process. Well, Edit Droid turned it into a digital process, okay? So it produced what we call nonlinear editing. So the third project was the Pixar computer. In those days, 3D, we were discovering ray tracing back in those days. I remember sitting in SIGGRAPH watching the first non-solid deformation impacts, right, with soft body collisions. Wow, really cool stuff, okay? I actually had 2 things shown in the electronic theater for SIGGRAPH over time, 2 different projects.
We interrupt this fascinating conversation to bring you a nostalgic flashback from the SIGGRAPH electronic theater from the 1980s while I was working at Atari. The Superman 3 director wanted a video game treatment for the evil villain to shoot down Superman. Of course, he looked to Atari to produce it, and I ended up with the gig, which was accepted by SIGGRAPH for the electronic theater.
He's here.
Good. Let's give him something to worry about. Nearly. You keep your rockets coming. He won't notice the missile until it's too late. So much for your cat-like reflexes.
My second SIGGRAPH screening was in the 90s while I was at CineSite. Famed large format director Ron Fricke was working with Arthur C. Clarke to produce a trailer about the infinity of mathematics using fractals. Up until that time, fractals were rendered with psychedelic colors, but Ron wanted me to use an organic palette for this 4K IMAX project.
I'm Arthur Clarke. I'm sure that many of you are familiar with the movie 2001: A Space Odyssey, which I made with Stanley Kubrick. Well, now I'd like to take you on another kind of odyssey, a mathematical one. Whereas in the Space Odyssey, we only went out a little way into the universe. In this odyssey, we're going to take you to infinity. Does infinity really exist? Is there anything that's infinite? We talk about space being infinite, but perhaps it isn't. It may be finite. We talk about time being infinite in both directions, but there again, that may not be true. The only real infinities are in mathematics, and it's usually difficult to visualize them. But here is one which you can see happening before your eyes. It's called the Mandelbrot set. To create it, we need only the simplest of mathematics, nothing more than multiplication and addition. However, those operations have got to be carried out so many millions, even trillions of times, that they could not have been performed before the advent of computers. It's one of the most remarkable and beautiful discoveries in the entire history of mathematics. I hope you will join me on an infinite odyssey in the auspicious year 2001.
At any rate, so the point being that we were all discovering all this wonderful stuff, okay? And the Pixar computer was supposed to be the solution for the enormous rendering problem. I mean, computers back then were like way slower than today. And so try ray tracing a scene, you were talking about hours per frame, okay? So the Pixar computer was supposed to solve that problem. The problem was the project slipped a year. Okay, it was a big hardware. Today we would call it geometry engines. Okay, GPUs. That was the concept. Okay, and it was going to render this stuff. Zing. Now at the back end of the Pixar, the gigantic machine, was a bit slice processor and a frame buffer, which they used to composite the layers that came out of the renderer. What they did was they cut that off of the Pixar computer and released it as a product. So it was a blazing bit slice processor that's a type of CPU, and blazing fast, and a big giant chunk of frame buffer. And this was an $80,000 box. And it actually jacked into the backplane of a 4D70 SGI machine. You guys even know what an SGI machine is? They're not even around, are they? Anyway, it jacked into the backplane of an SGI machine. That was the host, which then commanded the box. You sat at your keyboard, and the commands for the Pixar computer were literally an extension to Unix. So I would give Unix commands to talk to the box, but they were designed for the box. They were special commands for the box. So to composite a shot, I had to write like 2,000 line Unix shell scripts. Okay, so I became a very good Unix coder of necessity. Now here was the problem. This machine was very powerful. I had a stopwatch. I could rotate a 2K image, an affine rotate on a 2K image in under 7 seconds. In those days, that was blazing, okay? So the Pixar had 4K by 4K. You divided it up into windows. You said load from the file off disk into window 1, fill window 2 with this number, add those two together and place them in window 3. So you were doing the resource management of the machine. This was bare metal compositing. The problem was no manuals, no schools, no books, no teachers. This was a cold start. This was new tech. Nobody had ever done this stuff before. The software for the Pixar computer was designed, frankly, for medical analysis and spook satellite image analysis. It had all these image processing routines, okay? All kind of image processing. And it could composite. If you did this and then you did that and then you had to jump through hoops, but it would actually composite with an alpha channel, the over operation. It was 6 months before I thought I was smarter than that damn computer. But when I finished, I was able to sling pixels like nobody's business. Okay, and so I did television commercials. And then after I've been doing it for a couple of years, now I was delivering finished shots to the nice client. I was the only guy in town that could do that. Okay, so then after a couple of years of this, what happened was Kodak opened up the CineSite Hollywood office and offered 2K film scanning. Boom, I'm in the movie business. My machine will do 2K. Okay, I'm 10 bits per pixel in my processing. Whoa, okay. With 1 bit of over and underflow too, okay, for those round off errors, all right. I was king of the mountain, okay. So I was in the movie business, okay. Now, shortly after, a while after that, you guys, I don't know, anybody except the Wayback Machine, Disney opened up their CAPS division. CAPS was their digital cell animation. Okay, they drew vector scopes and they had pixel fills and all of that. And I said, well, wait a minute, I could do animation. So what I did was I hired an engineer who wrote me a simple, rather simple, fill program. I would take the line art and I would scan it on a flatbed scanner with the registration pegs. Okay. And I would scan it on the flatbed, run into the Pixar, slam the contrast so that the pencil lines became really black and hard. That was the inking of the cell. Then I would send that over to the SGI machines where we had the paint software. We had like a crew of 10 or 20 people doing click and fill, click and fill, click and fill, click and fill, okay? That would come back to me and then I would comp it over the background. I had an 8-bit color scanner. Yes, sirree. This thing could scan, they would paint the background paintings for a scene, okay? I could put it on this flatbed scanner, okay? And it literally had an overhead scanning camera thing and scan it in color, okay? So I had a color scanner for the background, colored pixel fill for the foreground, a big old Pixar to comp the two together at 2K resolution, and I had a big old film recorder. I had a Solitaire Cine 3 with an Acme camera, animation camera on it. And I could shoot high quality film. Ferngully was my first big animated feature. And so I did a lot of movies and a lot of television commercials doing digital ink and paint composite, doing that kind of a thing. So we got bought out. And so I moved on to CineSite, and CineSite in those days was the only game in town. They were really big. They had the Cineon software, which was a node-based compositor. I thought I had died and gone to heaven. I had been writing these huge Unix shell scripts, okay, to comp a shot, and I could drag nodes, and it was whoa, this is too cool. So worked on a lot of movies at CineSite because I was there for like 8 years. Well, after I'd been there about 6 years, Kodak decided that CineSite needed to actually make a profit. You know? Now, CineSite London was doing very well, but CineSite Hollywood was not really in the black. So in the meantime, Kodak had opened up the DI operation, digital intermediate. Okay. So we now had at CineSite Hollywood, all the film scanning stuff. We had the Cineon compositing software working on feature films, and then we had also the DI. Well, I went over and I made friends with the digital intermediate folk. Because, oh, this is new tech, you know, this is cool, I like this. And I became their go-to guy for image problems. I had a devious trick that I used to use. I read the manual. Cover to cover, okay? I was the go-to guy for everybody because I read the goddamn manual, okay? What a concept. Most people, tragically, they learn a little cow trail through the software, okay? And they never branch beyond that. There's old Japanese saying, if the only tool you have is a hammer, then everything starts to look like a nail. So you must learn the full scope of your tools. Okay. All right. So CineSite closed down the visual effects division, but they left open the digital intermediate division. That was still viable. They laid off all of the visual effects artists except for me. I was the one guy they kept because the DI department said, we need Steve. We want to keep Steve. So I had a job for another 2 years working with the DI department doing that. And, you know, that was, you know, Oh Brother, Where Art Thou? That was the very first digital intermediate film. Okay. And I worked on that. I helped the, Dr. Bogdanovich was the color scientist from Kodak. He worked all the color science for getting the whole pipeline working. And so, you know, that was a lot of fun. So eventually, though, I was an overpaid senior artist, and eventually they got tired of paying my salary, so I got laid off from there. Okay. In the meantime, I had published my book, and it was very well received. I got some offers for training and teaching. So in 2005, I started teaching and training, and that's what I do from that day to this, teach and train. It's gone through an evolutionary step. At first, when I got into it, it was Shake. I was teaching Shake. And I would visit facilities. I did facilities training. I would go do staff training, okay, and get them up to speed in Shake. And then, you know, I started thinking, after a couple of years of Shake, another profound development in the area of training was, y'all know Lynda Com? Okay, that Lynda.com is the world's largest database of instructional video tutorials, and they were purchased by LinkedIn. Are you sitting down? For $1.5 billion. That's how much they paid for Lynda.com. Now this is a gal that started in her kitchen. Okay, so what happened? I was teaching Shake, and I got a call from Lynda. Okay, this is in the very early days. Now, their forte at the outset, they were all internet stuff, you know, the web page building and stuff like that. So they decided they wanted to broaden their market. So they asked me if I would put together tutorials on Shake. Turns out my wife is an editor. So I could sit at my machine and I could use a screen capture software, and I could record my tutorials and Shake, blah, 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 give them to Diane, and she would edit them together. We delivered turnkey finished tutorials in the first time they'd ever seen that, because what their normal flow was, they flew you into the studio. You did all the work in the studio while they recorded it, and then they did the editing. You went home while they did the editing. Okay, so we delivered finished product. So that was my first, that's what got me in heavy into the whole teaching and training thing. So after a couple of years of Shake, I'm scratching around going, okay, what's going to be the next big thing in compositing? And I said, 3D compositing. That's the, Shake had a little 2.5D thing. After Effects has a very, very minor 2.5D thing. Okay, I'm at full up 3D compositing. So I go to the NAB show. When was that? That was 2008. I went to the NAB show, and I went to the Foundry booth because I found out who does 3D compositing, and Nuke was the only thing. Okay. So I go to the Foundry booth, and I grabbed the VP of marketing, and I said, I want to teach Nuke. And he said, thank you. Because here's what had happened. The Foundry had acquired it from Digital Domain. They were trying to sell it into the visual effects studios. And the first question the studio would ask them is, where do I get artists, trained artists on Nuke? Well, you have to go hire them out of Digital Domain. Okay, that was not a good story. So they were falling down grateful. They gave me all the software I could eat, engineers, documentation, anything I wanted. Okay, here, go. And I became a Nuke trainer, the first Foundry certified Nuke trainer. Okay, so then the world switched to Nuke, and the Nuke was a paradigm shift for the visual effects industry. Okay, Shake was a node-based compositor, but it was really, 8-bit, it was really, Shake was video-centric. Nuke is film-centric. If you have any doubt, you would fire up Shake and the timeline 30 FPS. You fire up Nuke, the timeline 24. Okay, so there's your first clue. So I got really heavy into Nuke, and I read all the documentation and their white papers on their color space, this linear light space thing. What the heck is this stuff? I read their white paper and I went, oh my God, this is the answer. At CineSite, I watched the engineers writing CGI. They were writing software for CGI, okay? Like for Sphere, they wrote a particle system, a subsurface scattering particle system for the cloud effect in the Sphere. They never were able to get a CGI image to properly composite with log film scans. And they tried all different approaches and nothing really worked well. And when I got into the linear light space for Nuke, I went, this is it. This is the answer. This is why they couldn't do it. Because to do this correctly, you have to, 1, be linear, 2, float. And back in those days, we were all 10-bit integer. It was never going to work. I became so excited. I love the math, I love the science, I like color science. I learned about log films from Glenn Kennel, the color scientist at Kodak that invented the log films math. And so I got very excited. I wrote an article about it. Okay, this whole Nuke linear light space, this is it. This is really cool, people. And said, before I publish this though, I think I'll check it with the Foundry. So I sent it to the Foundry and I said, hey, would you ask the lads to look this over and make sure I told the story correctly? So about 2 days later, I heard back from them, yeah, not only did you get it right, we've been trying to get this story out there, nobody gets it. Could you make a video for us? So I did, and it's still on the Foundry's website, okay, Nuke's linear light space.
This is Steve Wright for the Foundry to talk to you about Nuke's amazing color management system.
So that kind of got me deeply embedded with the Foundry, and I traveled around the world. I've been to, like I said, I've been to India 11 times. I think 9 of those were for Nuke. So in those days, I was very heavy. The world was ramping up to Nuke. In sales and marketing, we call that the sell-in. That's getting the stores to carry your product. Well, now everybody carries the product. Okay, so my location-based training tapered off dramatically because everybody is now nuked up. I nuked up Pixar, okay, India, Malaysia. So in Canada and a few spots here in America. But the point being that the traveling to the studio facility has tapered off. And so I switched to much more of an online thing. LinkedIn Learning, my own website. So now I do, I record tutorials, and we sell those tutorials, and that's how I make a living today. Any questions?
I'm exhausted already.
Yeah, it's a hectic career.
Yeah, that's absolutely fascinating. Yes. Do you want to take some questions now?
Yeah. Anybody got a question before we jump into heavier stuff?
I think Pietro wants to ask you what an SGI machine is.
Oh. Okay. SGI is short for Silicon Graphics Incorporated. It was a machine that had built-in geometry engines, what we today call GPUs. And inside the chip, instead of a CPU, as you know, just executes your software with one machine instruction at a time. But the GPU it's all encoded in hardware, and it's like up to 50 times faster. Well, the geometry engines had hardware built in that would do like raster line, pixel fill, polygon fill, shaded curved surfaces. So the SGI machine was the first machine that could put up real-time 3D. The first machine, other than the Evans and Sutherland PS200, of course. That was a vector-based machine actually made, I wander. Anyway, back to the SGI machine. So it had the ability to put up real-time 3D geometry. So at the beginning of the CGI industry, they were the machine to have.
10, 9, 8, 7, 6, 5, 4, 3, 2. This demonstration video is taped directly from the display monitor of the Silicon Graphics Iris 2400 workstation to 1-inch videotape. No special video editing effects are used. Motion display sequences such as the one you are now watching are taped in real time as they run on the workstation display.
As long as you had space for a fridge and $500,000.
Well, actually, it wasn't that. It was about the size of a desk. It wasn't that. No, those machines were 4D70 was the second generation.
Yeah.
40 or 50 grand each, I think, something like that.
We'll do with the octanes.
Yeah. Well, the octane is.
that was much smaller, wasn't it? Yeah.
Oh yeah, very much so. Mm. But so that was the foundation machine for this. Now today, we have CPUs that are so fast. We have graphic cards that are so quick that we got machines now that can put up a real-time CGI on your screen without using geometry engines. Okay, these video cards have got pixel fill routines and all kind of hardware implemented graphic code, and so they can put stuff up really fast. What blows me away is the video game industry. I started off at Atari, but we were doing 8-bit sprites. I mean, that was Tinker Toys, okay? But today in the damn video game machines, they can do real time ray tracing, ambient occlusion, dust particles. My God! But the thing, those game machines are nothing but stack after stack of GPUs and geometry engines. Anyway, so that's the SGI machine.
Thank you very much.
More than you ever wanted.
Shall we crack on with your presentation, Steve?
Righto. Do we have any time left? Yeah.
How much time have we got?
Are we going till for another 45 minutes?
If that's okay.
Oh, well, yeah, sure. My time is yours.
Thank you.
The question before the board is, we have 4 general topics here. Keying, I got some tips and tricks to show you for keying, some techniques for despill, a lovely lecture on linear light space and why it's so important and how you're going to die if you don't do it. And then I have another one that's on premultiply, unpremultiply, a topic that vexes most compositors, and we don't even know why we're doing it, but we have to do it. Don't even know what it is and why in the hell do they call it that. So of those four things, let's start with, how about some premultiply, unpremultiply? Okay, John thinks that's a good idea. All right, let me get that set up here.
I'm not gonna don't let me influence you. Your choice.
I'm getting my Duke fired up here. Okay, everybody got this? Okay, tragically, one of the big problems with the whole premultiply, unpremultiply thing is the name of it. What the hell am I unpremultiplying? Well, let me tell you a story. In the beginning, when CGI was first invented, they were rendered out in two separate passes. You had the original RGB image, which was rendered out, of course, you know, as 3-channel RGB. And separate from that was the transparency channel. Those were two separate images that were given to the compositors, right? So what they had to do was they had to multiply them together. So he took the raw RGB, no anti-aliasing, no transparency at all, just the true RGB color of the pixels. You CGI guys know what I'm talking about. Multiply it by the transparency to get the multiplied by transparency version, which is what we use to composite. And there's my nice semi-transparent alpha channel and anti-aliased edges, okay? Everybody comfortable with this? Well, after doing this for a while, the compositors said to the CGI people, hey, we have to multiply your stupid transparency times the RGB every single time you give this to us. So do us a favor. Would you please pre-multiply it for us? And that was how we got the term pre-multiplied. Okay? It means the raw RGB has been multiplied by the alpha channel, and it came to you pre-multiplied. Okay, you don't have to do it yourself. Well, now everything comes to us like this. So this is no longer, but you go, what do you mean pre-multiplied? That's crazy talk. Okay, so that's one source of the confusion. So if I unpremultiply it, I restore the original RGB values if I unpremultiply it. Now, listen very carefully. Unpremultiply is to take the premultiplied image and divide it by the transparency. And that's what gets you unpremultiplied. You're backing out. Remember, in the first place, I multiplied RGB times alpha. Now, if I divide RGB by alpha, I get my original RGB back. Okay? Well, that is the name of the game for an unpremultiplied image. But now, here's the bad news. We now have 3 terms. 1, this is a premultiplied image. This is an unpremultiplied image. This is a not premultiplied image. You'll even see those terms. I'm going to show you those terms in Primat. They actually use those exact terms. Okay, so now back to the real world, okay? We get all of our stuff from the CGI department pre-multiplied, and if we perform an unpremultiply, we can undo it. But that's the story of premultiplied and unpremultiplied, okay? Now, the problem is we need to look at the workflow situation. There are certain operations in our world that must be premultiplied. If you don't, you will die. Okay. A blur operation. The image must be premultiplied to look correct. Here's my blur. I am blurring also the alpha channel. There, okay. There's my blur on the alpha channel. Okay. If I were to perform this on the unpremultiplied image, and what I'm going to do here is I'm going to turn on, here's my original jet. I'm going to unpremultiply it, do the blur on that, and then premultiply it and then composite it. Okay. So here is the result. You cannot perform the operation on the unpremultiplied jet, or you will get the wrong results. Okay, also transformations, okay? This has a little rotate, just a small few degrees of rotation. I think if we look here, okay. Okay, now, this is the premultiplied jet, rotated and composited. I've unpremultiplied it. There you can see the bad pixels popping up on the back of the jet, okay? So, blurs and transformations, filtering operations and transformations must be performed on the pre-multiplied image. These are the operations that must be performed on the unpremultiplied image. Color correction and, most importantly, color space conversion must be performed on the unpremultiplied image. So here is my jet. Okay, and look at the difference. This is correct. Okay, what's happening is this is the color space conversion in Nuke. I'm duplicating it here so that I could do it outside of the read node. As you Nukers know, but CGI folks may not. Inside Nuke's read node, the whatever type file it is linearized. We back out the sRGB, we back out the whatevers, make it linear. That is a color space conversion. If you do that color space conversion on the unpremultiplied image, excuse me, on the premultiplied image, you will introduce these dark edges, these anomalies here. Okay. So you must do it. And in fact, now we can see here, get my read node. Nuke has a, let me move my people down here. In the read node, Nuke has this button right here. This says, when I turn this on, it says, yes, this is a premultiplied image. So Nuke, inside the node, quickly does an unpremultiply, color space conversion, then remultiply. If you turn it off, then Nuke does not perform those operations and you get the bad edges, okay? All right, so it's actually built into the very structure of Nuke's software. Okay. All right. Gee, everywhere I move this thing, it's in my way. I'm moving your, okay, color correction is another area of misery, okay? Look at the difference, okay? This grade node, I jack the gamma up, and look at I disabled the grade node. Look at the difference, whether I perform this on the premultiplied or the unpremultiplied image, okay? Right now, this is what happens if I try to do it on the unpremultiplied image, and that is the premultiplied. This is correct. Now, what happens is Nuke has addressed this by baking it into every color correction operation, like the read node. Every single one of these operations here in the color tab have this right here, unpremultiply by. So in this with this grade node here, if I try to do a gamma operation and I don't turn that on, see the difference? Okay, so every color operation should go unpremultiply, color correction, remultiply. Okay, in this order here, unpremultiply, color correction, premultiply. And that is how your color correction will be correct, okay? There is a trap, you have to be careful, okay? You get the foggy background plates, okay? What the heck is going on here? Well, what happens, people, if I did a grade operation, or I did a lift on the red channel, or the black point or something, or raise the black point, remember, your CG out here is supposed to be surrounded by zero black. Well, if I perform the wrong type of color operation, I'm going to get, I can contaminate that black, which then gets laid over my background plate. Okay, I've got that red fog over my background. So what you do then is you first unpremultiply the thing, do your color grade bad, then you apply the premultiply, and boom, you've cleared it back to 0. Now it's safe to do your composite. And once again, Nuke, in their brilliance, has baked that also into every single color correction operation. Here's your unpremultiplied by alpha. Okay, if I turn that off and on, you see, it fixes my background. So you must have unpremultiplied images for color correction and color space conversions. Now we have keying issues when we run a keyer, okay? So, you know, we've oh, by the way, I was going to show you in Primat. All right, so I have made a key, and the default output of Primat is premultiplied, okay? In fact, I'm going to move these over here so I can push in here. Everybody see, can you see this? Okay, premultiplied. So this is the output when it's premultiplied. Here is its output unpremultiplied, and there you go. You see, it's reversed all these edge pixels, because there was noise out here which got reversed as well. But it's divided it now by the alpha channel, so we now have the nasty hard edges. And then they have the not premultiplied, which is your original green screen. So even Primat gets it. So the workflow is you start with your green screen, and you pull your key on it. Okay. Again, this is the external key. I know beginners like to try to key in the keyer, because the salesman said if I plug in the foreground and the background and I twiddle the knob, I get a beautiful composite. That only works with the sales demo footage, okay? The real world, your stuff is not going to make a pretty key by plugging them both in. So what we wind up doing in the real world is a more tedious process. We use the keyer to create our key, but we will do our own spill suppression. We will follow that by the color correction, and then the color corrected despilled image, we pipe the alpha channel in behind it. Then we do a premultiply on it, and then we composite it. Okay, so that's the way the big kids do it today. Okay, so we have to be aware that we are doing this with this color correction operation that I put here is being done on the not premultiplied image, okay? So I'm doing my color correction prior to the premultiply, which is correct. I can now gain these guys up and down with impunity without damaging my edges. This is where people get into a lot of trouble in their visual effects, is they'll perform accidentally perform 2 or more premultiplies in their workflow without realizing it, okay? What I've done here, I've got a very simple, simple, silly little thing, and I'm going to, which is already premultiplied. This is a premultiplied CGI object. How can I tell? It's black out here, nice anti-aliased edges, solid core. Okay. If I perform another premultiply on that and composite it, look what happened to my nasty edges. That second premultiply turns the edge pixels blacker than they were before. And then you do the over operation, and now you've got dark edges, okay? The problem is that people failing to realize this, the right answer is go back up the pipe and find where in the data stream you perform the second premultiply. But what a lot of people try to do, I'll do some edge correction to kind of fix this. Okay. So you start laying in compounding errors. Okay. So if you get your dark edges, you got to go find the double premultiply. You can do it in CGI, of course, you know, if I got my lovely jet here. And should I be foolish enough to perform a double premultiply, God will punish me for it. Okay. And the read node, the key is that in the read node is performing a premultiply in there. And if I accidentally get a double premultiply going, my CGI will introduce dark edges. Okay. You can also get, obviously, you can do a double premult on your keyed images. This is where a lot of people get into trouble. Okay, it's keyed edges. So out of my keyer, if I add a premult when I shouldn't have one, ooh, looky, I'm losing my hair. I no doubt have soft edges. This is ugly, ugly stuff. Okay. So that is the issue there. Now where you can also get bit in the butt by the double premult is if you're working with the admix node. Okay, we know and love the admix node, right? The admix node was made for keyed images. This allows, these curves here allow you to individually adjust the foreground and the background edges as the transition between the two layers, okay? And it's very lovely, but it has this little button right here, premultiplied. Clue, this is a big clue. What you have to tell it the truth. Coming in is a premultiplied image. Okay, so in my admix node, I have got to say, yes, this is a premultiplied image. Then I get my lovely comp. But if I lie to Nuke, if I say, no, it's not, it's going to perform another premultiply inside the admix node without asking. Okay, so the admix node can get you premultiply problems, and you won't even know it. There you go, some lovely hand action. Okay, so watch out for the key mix node. You must tell it the truth, okay? And the trouble is, you look at this and say premultiplied. Well, does that mean it is premultiplied, or I want it to be premultiplied, or it used to be premultiplied, or I wish it was premultiplied? That says the incoming image is premultiplied. So tell it the truth, or you will be punished. There's a lot of punishment in this business. A specular highlight premultiply, yeah, that's kind of an obtuse issue. Let's do something. Yes.
Can I ask you a question?
Certainly.
Would you think it's better to use the unpremultiply, do whatever you want to do the image, and the premultiply node in order to troubleshoot problems, especially when multiple people have to access the same script?
Yes.
Or is better doing inside the node, for example, inside the grade node?
Well, inside it's baked into the grade node, it's baked into the read node. Okay, you should use those there. However, there are other internal operations. I've had experienced line supervisors tell me, for example, inside a grade node, you have, for the alpha channel, you have an invert button to invert the alpha channel, right?
Yeah.
The problem is somebody looking at your script may not know that. And all of a sudden, the comp gets kind of hard to understand. They want to see an external invert node, so that you go, oh, they inverted the alpha channel. Okay. Okay. However, the premultiply, unpremultiply thing should be done in the read node or the color correction nodes as designed. Okay. As designed. Question. Are Photoshop PSD files, are those premultiplied or are they unpremultiplied?
May I reply?
First years have to answer this, otherwise I'm going to go through this again tomorrow, Steve.
Yeah, okay.
Just did this on Monday. The first years have to say something.
Yes.
I'm sitting with my head in my hands.
Well, here in Nuke, I have busted out, using nukes. These are the layers from a PSD file. This is a PSD file. And then in the read node, you say, yes, please break out the layers. And Nuke breaks them out for you and builds this lovely little assembly. And each and every one of these is unpremultiplied. Look in the alpha channel, okay? We go and put it all together, and now I can see text, but up here, I got a yellow block with the word text behind it. But when you put it all together, you can see the word text, you get your soft edge things, and like that, okay? Now, here is the problem with Nuke. I'm bringing in the raw PSD file, and I'm attempting to duplicate it in Nuke, okay? And I do not get the correct answer, okay? You see the differences here in my edge stuff? In fact, if we look really close, you'll see some differences in the anti-aliasing of the text, okay? In fact, this merge node is set up for the difference, to show you what's different about the two, okay? The reason this is all happening is because in Photoshop, they're working in sRGB screen space, and they're doing all their math, color correction, and compositing and premultiplying in sRGB space, which is wrong, but that's the way it is. We bring it into Nuke, and Nuke tries to do it right, okay? So they don't look the same, okay? Well, if you will, you can match a PSD file. A little bit later, when we'll talk about linear, working in linear, I'm going to show you how you can work in sRGB in Nuke, okay? And there's a couple of reasons why you might want to be able to know how to do that. But I can match it if I will do it correctly in Nuke. I gotta move you guys away from my, there. Okay, so this is my Nuke composite. This is the original PSD file. And now as I toggle between them, they are absolutely identical. The reason is I tricked Nuke into working in sRGB space, so I could match the results in Photoshop, okay? So that's my story about premultiply and unpremultiply, and I'm sticking to it. Okay, working in linear, okay. These are the three key questions. What is linear data? What is the linear workflow? And why should you work in it? What kind of trouble do you get in if you don't? What are the artifacts? Okay, so what's linear data? That means there's a one-to-one relationship between a pixel's code value and its intensity. When you work in linear, if you double the code value, you double the brightness. Let me rephrase that. You double the luminosity. Brightness is a human perceptual word. If I double the brightness of an object in the physical world, to the human eye, it appears to be 18% brighter. Because the visual system is nonlinear, horribly nonlinear. And thank God, because our visual system puts a huge gamma curve on the world. It brightens the darks and it rolls off the highlights. And the reason it's brightening those darks is so that I could see the tiger hidden in the weeds. And the reason it rolls off those brights is so that I can go out into broad daylight and the sun will not burn my eyes out. The human visual system, properly adapted, has a dynamic range of 1 billion to 1. Now that's adapted vision. That's adapted vision. Makes these Christie projectors look like Tinker Toys. Okay, so this is a linear image. Original scene, these numbers over here represent the code values of it. And this is a linear ramp showing how there's a one-to-one relationship between the pixel code value and its apparent brightness. This is a linear image. So why aren't all images linear? I mean, it makes perfect sense, right? Well, because of television. Here's what happened. We invented television back in the 30s or the 40s. Who was that crazy guy? The guy, inventor of television.
John Logie Baird.
Oh no, that's not who I'm thinking of.
He invented TV. Scottish, of course.
I.O.T. Farnsworth. I.O.T. Farnsworth. Now maybe he was the American inventor, so he's our hero. All right, so here's what happened. We start here with frame 1, which is the display intent. This is what I want my picture to look like, okay? If I put it on a CRT monitor, it suddenly darkens down to look like number 2. And it does that because cathode ray tubes, if you double the voltage, you do not double the brightness. Cathode ray tubes have this non-linear curve here to darken the image down. This is in the physics of the cathode ray tube, the emitters and the electrons and all like that, okay? So what they're looking at this and going, okay, this is way too dark. What are we going to do about this? Well, there's 2 solutions. So one, we could have every single television set have a gamma increase baked into the design of the TV set, or instead of doing 10 million TV sets, we could do 1,000 video cameras. So they baked into the video camera the gamma correction, okay? So the image produced by the video camera has got the opposite curve baked into it, and the image is artificially brightened like this coming out of the camera. Then you put it on your TV screen, which darkens it down with the counter curve, and we're back to our original display intent. So tragically, we've been living with television now for almost a century. Everything has this gamma baked into it. Now you're saying, well, wait a minute, we don't have cathode ray tubes anymore. We have these lovely flat panel displays. Yes, we do. And the flat panel displays do not have a gamma curve in them based on the physics of their cathode ray tubes. So what they said was, there are millions of television sets. There are billions, maybe trillions of pictures and video out there. For them to look right on the flat panels, the manufacturers are going to bake in a fake gamma curve. So all your flat panels also have the same gamma curve as a CRT. So now all your digital cameras, all your video cameras, everything that makes a picture except for CGI bakes in this gamma curve here, and this is a non-linear image. Tragically, if you talk to a video engineer and you say, well, is video linear? He'll say, well, yes, it is. Of course it is. No, it isn't. It's gamma corrected linear, but it is not linear. If I double my code value, I do not double the brightness. So what is the linear workflow? It's to convert all incoming images to linear to prepare them for the proper image processing. So here's the 4 steps to a linear workflow. You linearize incoming images, all image processing done on the linear data. You use a viewer LUT to view the linear data because it looks too dark natively. And then we bake in a display LUT when you render it to disk. You render it out as a TIFF or not DPX, that'll be a log, but you render it out. You have to bake a LUT into it so that when the next guy picks it up, it'll look okay on his monitor, okay? But it's no longer linear data. So here's the linear workflow, okay? Number 1, the images right here again, I'm doing Nuke, of course. We linearize the images upon ingest. Inside, during all image processing, they're all processed in linear. It goes up to the monitor, and there's a display LUT to make it look pretty. And then on the way out, it's exported with a baked-in display LUT for a TIFF or a Targa or a JPEG or anything like that, or a ProRes. DPX, which is very common, that's not so much a display LUT as it is a log curve, but still it's the same principle. So that's the linear workflow. However, there is a trap you need to be aware of when converting images to linear. Okay, and there's no problem with 3-channel in 3-channel images, but with 4-channel premultiplied CGI, because they're going to give it to you as a TIFF or a target, maybe EXR, I don't know, depending on where you're working. But if it comes at you with a LUT baked into it, then it has to be taken out. Okay, and you have to be careful. Remember earlier I was telling you about the premultiply thing? The CGI is premultiplied. If I do a color space conversion on the premultiplied CGI, I got troubles. So the warning is, for CGI, you have to first unpremultiply it, then convert it to linear, then premultiply it, and off you go. So why do we have to work in linear? Because it is both mathematically and visually correct. Here are the virtues of the linear workflow. You get correct image blending results. You get correct color correcting results. You get correct filtering and transformation results. The proper merging of CGI render passes, and you are able to mix images from any source. Because remember, we're bringing in, log film scans, ProRes Rec 709, a photograph that's in sRGB, a picture of my mom, and we're putting them all together in one composite. Well, try combining those images, leaving them in their original color spaces. You'll never get them to match. But make everybody linear, then they play nice together. And the results are then converted back to some. Here's one example of a simple image operation and the huge difference we get. On the left, I have a middle gray. This is in linear, that I have summed together. Now in linear, 0.22 is a middle gray, 50% gray. I sum them together. Obviously, I'm going to get 0.44. I do the same operation in sRGB. 0.5 is a middle gray. I sum them together, and I get this huge white spot. This over here on the left is what it would look like if you took 2 spotlights and crossed them on a stage. It would look like that in the middle. It would not look like the one on the right. Okay, because linear is in fact a simulation of the real world. So here's why they look so different and goofy. The linear image up here is very, very dark. This is seen without the display LUT. They've been summed together in linear space. We then lay this big old LUT on it so that it looks like this on the monitor. Whereas here, like if we were in Photoshop and we sum together these 2 plates, then you're going to get this silly overbright image. So in image blending, the over operation, if we composite them in linear, it will look nice. In sRGB, it'll look wrong. So I'm bouncing between the 2 here to show you. Okay, this is the same image, just one composited in sRGB, the other composited in linear. Also, color corrections. Okay, on the left is a linear image, on the right is sRGB. I'm going to double the brightness of both images and look at the huge difference in results. Original, 2x. Original, 2x. The linear image on the left looks natural and correct. Filtering operations should be done in linear space. Now, filters include blurs and median filters and also transformations, because when they do a rotate or a scale or anything, you are performing filtering operations on the pixels, okay? Look at this. Here's my grid, and on the this is performed in linear space, the blur on the left and the rotation on the right. The results look very good. Same grid, same operations done in sRGB space, and the blur on the left, look at the little knots at every intersection. And of course, the lumpiness of my rotated lines. That's the result of performing filtering operations in not linear space. Compositing CGI. very important because we have to be able to blend the lighting passes together to duplicate the result of the beauty pass. Okay, and CGI works in linear. All those renderers internal to the CGI computation, those are all linear operations because CGI is a simulation of the real world. And the real world is linear. Our vision is not, our hearing is not, but the real world is. So to replicate it correctly, we must be in linear. Now on the left is the beauty pass. In the middle is the linear composite. So this was done, the separate layers were composited in linear, and you'll notice it matches the beauty pass very well. Here, the sRGB comp, the same layers are summed together in sRGB, and the results are very different and quite wrong. So for CGI, you have to linearize all your passes, merge all the layers, and then use a viewer LUT, and then you bake in a LUT to write out your finished shot. So the other thing about linear, it allows you to mix images from any source. And today we live in a real grab bag. Okay, another war story. Charles Poynton is a huge man in the world of color science. He works on ICC profiles. He's hired by corporations and Microsoft and all. I went to one of his lectures. It cost $600 to attend this thing. There was about a dozen people in the audience. So we just get started and some guy raises his hand and he says, "What do we need color science for?" And I'm going, "Why the hell are you in here? Okay, what are you doing here?" And Charles Poynton was caught so flat-footed by that question, he just stood there and stammered. So I raised my hand and he said, "You, yeah, you." So I said, "If you work in a closed color pipeline, video in, video out, film in, film out, you don't have to worry about color science because the color scientists have taken care of it for you. You're locked in a closed color pipeline. The minute you cross between color pipelines, you need color science." And Charles goes, "Yes, on the nosy, on the nosy." And that's what this is all about. Okay, I can take all these different images, linearize them, and mix them together, and then I can write them out in any kind of a color space I want. And this is how we properly manage the situation with linear color space. And of course, floating point, got to have float. And the thing is that, you know, linear color values are weird. You got to get used to it, okay? It's kind of hard on your head. And some important file formats. These file formats all have color space assumptions baked into them, okay? EXR, by definition, is linear, intrinsically linear, okay? And Nuke gets it almost right, okay? Because Nuke linearizes the images, okay? So that's a giant step towards the correct workspace. However, it does not account for the capture camera's bias. All cameras see the world a little bit differently. They don't have defined color primaries. And so, so you get a problem with the linearized images are not really what we call scene referred, which is what ACES is about. This is the purpose in ACES, the Academy Color Encoding System. It moves that ball the last 10 yards. Oh, I'm sorry, that's an American football reference. You're soccer people.
We got it, don't worry, we got it.
Okay, I don't have a soccer metaphor. ACES backs out the camera bias. Every camera manufacturer offers a table characterizing the camera's performance for ACES so that we can back out the camera's bias, and the data now represents literally the photons at the scene that you shot. And that's called scene referred data. It also moves the data into a huge wide gamut color space, so large you can't possibly clip it, so large you could never build a display device that could show all the colors. okay? And all of the color correction is done in this linear space, and then you can output ACEs in multiple formats. This is the overall workflow here for ACEs, and we're almost done, by the way. On the left, these are your different cameras, and input device transform, the IDT, that's where we back out that camera's characteristics. Then the orange box with the scene referred data. We now have the data converted to what it really was, the light of the original scene. Then the yellow box ACEs, that is this huge dynamic color space, okay, that you can't possibly exceed. The RRT is the rendering transform. That is taking the ACEs linear data, which looks ugly and awful and dark and hideous. That converts it to a film look. That's kind of the standard reference for what this image should look like. Okay, that's the RRT. Then you perform your color corrections or changes and whatever you want on that. Then the ODT is the output display transform. That is the specific transform of that data to make it look right on the different display devices, okay, that you might be working with there. So that's the story of ACEs. I'll stop my share and go back to me. Well, we didn't get to do despill or keying.
It's a great shame. This has been great so far. Are you okay to take a few questions, Steve?
Oh, of course, of course.
Anybody want to ask Steve anything at all?
Can I jump in?
Yeah.
Go ahead.
So you said 3D compositing was the big next thing in 2008, I believe.
Yes.
What's going to be the next big thing in comp?
Very interesting question. Mumble. Well, as opposed to a single identifiable new technology, I think I would like to point to an overarching trend in compositing, which is where more and more of the 3D is being done in 2D. Classic example, normals relighting. Okay, I can relight your CGI with in comp. Okay, I remember I attended a postmortem on Night at the Museum 3, and because I'd worked on Museum 2, so I was interested in what they were doing, and the CGI super was saying, or VFX super was saying, we had the CGI department just blast out the layers. Don't tweak them. Don't polish them. Give it to the compers. I hate compers. We are composite. We're compositeurs. So they would give it to the compositors who would bring it in and give it the final look. Okay. So that trend, I mean, rendering Fresnel passes, the number of AOVs. Y'all know AOVs, right? Did you teach them AOVs, John? Okay, good.
Yes, Ian teaches all that stuff, yes.
Marvelous. So, I mean, in all the large shops now, when they render a CG shot, they have a stack of layers. No matter what, we're always going to render these passes. We no longer sit and say, okay, for this shot, I want these 5 passes plus all your lighting passes. They have this long list, and they just blast them out, and the compositors get them and give it the final look. So in compositing now, we are becoming the finishers. Okay, and even a lighting compositor. Okay, they'll redo the lighting and dial in the shaders and run the render that way themselves. Okay, so that's having the 2D guys with their fingers in the 3D department. So more and more is being moved into 2D because it's faster. Plus, more girls. We get more girls. Yeah.
So a compositor is asked to also be way more technical and way more artistic.
Absolutely true. You actually need to understand. You got to talk to a CGI guy. You got to talk about surface normals and deformation lattices. You got to speak CGI speak plus your own 2D speak and be an artist. Okay. In the past, visual effects supervisors were all 3D guys. In the last few years, a few compositors, Pat Tuvok at ILM, compositors are becoming visual effects supervisors.
Snape, ILM London, one of ours. He's a compo. He's the supervisor at ILM now. Snape, ILM London, one of ours. He's a compo. He's the supervisor at ILM now.
All right, I rest my case. So bottom line is compositors are becoming progressively more important over time.
Have you looked at any of the technology which is automatically keying things out? Have you seen anything that works?
Well, not yet. There's great hopes for artificial intelligence. I am less sanguine about that. I think our jobs are quite safe for quite a while. There is a very large opportunity for human-assisted tools. Okay, the machine gets a little smarter so that we can get a little dumber. But as far as real AI, because the problem is when you look at the transition of like between the foreground and the background of a character on a green screen or a character in a room, which we could roto, okay, slowly and painfully, but we certainly could. It becomes ambiguous. It becomes a judgment call. Which pixel is fractionally in which side of this equation? AI will never accomplish that. Okay, because remember this, in compositing, it's all about the edges.
Indeed it is. I think I can hear Ian cheering. Even those mics off. Excellent. Have we got time for another question? Anybody got any more questions quickly?
I'm good.
Terrence, fire away.
Hey, Steve. Thanks for your knowledge and the banter. I have a question. You know the denoiser for Arnold?
I don't know the one for Arnold, no. But
yeah,
I know the denoisers in general, yeah.
There's one that's meant to work with it. There's a script for Nuke called Noise.
Okay.
That was developed. I wanted to ask you if you know if it's better than the traditional method of like denoising within Nuke, or does it actually help the process?
Okay, I can't speak to their denoiser. I can speak to Nuke's denoiser, but not theirs.
Because I'm a CGI person, one of those people. And I was in Nuke and I saw that it had this like noise thing, not noise, like with a C. And I was like, yeah, okay. So I looked a little bit into it, but there wasn't any kind of real structured kind of conversation to say if it's actually beneficial for the compositors or not.
Yeah, the whole key to denoise is to actually remove the noise without removing any sharp detail. That's the holy grail of denoise. And different algorithms have different ability on that. Nuke's denoise is very, very good. It's a B+.
Cool. Thank you.
You're talking about neat video there with the C.
Sorry?
Neat video use noise, yeah, which is a well-respected plugin. Yeah, that's what you're talking about. We have it at the school. We won't have it.
Yeah.
I think did Sean, were you going to ask something? No.
No, I think Pietro asked a really good question, but I think Karina's got one.
I was going to say, I've just seen Karina appearing. Karina, go ahead.
Thanks, Steve. That was great. I was just wondering what you think about real-time rendering, because we've heard from a couple of people oh yeah, real-time rendering, compositors won't be needed, and what does the future look like with that developing?
Well, that is a scary truth. The geometry engines and the GPUs are getting faster and faster and faster. And what's happening is you're now getting into a point where you can literally turn the dials while it's rendering and see the images. Okay, I don't think that we're ever going to not need a compositor, because they're talking about rendering the CGI, but when you talk about laying it over the background, now there's some magic has to occur. Okay, I don't think that it'll be a long time before they'll be fast enough to do the rendering and the compositing in real time. Because I mean, we sit there and we're compositing the CGI over the live action. We're cutting a little roto around the guy's finger to dial in the background fall off of the shadow, you know, to try with all these little cutty pasty things to make it look. Now, if you lower your standards, I think you could be okay. But but the filmmakers are always want everything, you know. Because I've watched this technology grow from a very early state, and I noticed that we would add these fantastic new ray tracing, you know, ambient occlusion, big new things, right? And we say, okay, now finally, we're going to be able to produce what the director wants. But what I've observed is that the creativity expands to fill the technology. Okay, they keep demanding more, and more. So yes, that's going to be a productivity tool, but I don't see it fundamentally changing the workflow.
Oh, that's great to hear. I'm glad you think that.
Yes, there will always be a need for a compositeur. Okay.
So linking to this, don't you think like the giant LED wall that ILM created for the Mandalorian is gonna be like the future, the next 10-year technology?
A giant LED wall. Oh, you mean for theatrical projection?
For production, virtual production.
For virtual productions.
Oh, well, virtual productions.
Yes, well, they're taking it all with them to the studio and playing it behind the actors and recording the whole thing in one go, theoretically.
Right.
Theoretically.
Well, they're working on LED screens for movie theaters because there's an upper limit for how bright we can make our Christie projectors. Okay, there's a practical upper, and people want more photons. So they're actually going to have 60-foot LED panels in the theater one of these days. Okay, you're saying that they're using them as a backdrop to shoot the talent in situ. Okay, you put the CG world behind them. Okay, well, okay, I got two questions about that. One is, of course, dynamic range. The LEDs have a limited amount of dynamic range, and I'm not sure how hot you can burn them. And the other is, don't forget, it's a flat panel. So you got a character standing in front of a flat panel. Well, can I do this with my camera? No. I'm going to have to kind of keep everything pretty much out here. And of course, there's going to be some pin cushioning going on in that, because that is a flat screen. Okay, and there's certain optical limitations to having it on a flat screen. So I'm sure it will be useful for some things, but I don't see it becoming the rage that replaces everything. Remember, that's a flat screen. Okay, yeah. It's only so much you can do with that.
Thank you.
Mm-hmm.
I'd like to ask a question actually quickly.
Sure.
So I imagine with virtual production, you've heard of the Unreal Engine and how that's starting to make an appearance more and more in the industry, and how that can do real-time rendering, make viewing CG much faster. Right. In the past few months, there's also been developments on that they want to introduce compositing workflow into the Unreal Engine. They're adding compositing tools, and I'm wondering what you might think, what sort of paradigm shift that might have on the industry, with it being on a free platform for people to use.
On a free platform?
Yes, Unreal Engine is free.
Well, it's okay. What am I thinking of is the game machine?
Yes.
But that's a very expensive box.
Oh no. It's just the Unreal Engine is a software you can download.
Well, the software has to run on my workstation, and my workstation.
Yes.
Has only got a limited amount of CPU power.
Right.
Okay. For that. So Unreal is actually, that's the software that runs inside the Unreal geometry engines for gaming machines. Okay. If you don't have the hardware, you're not going to get the speed that you need. I got a 12-core monster machine here, and so it's got a lot of horsepower, but it couldn't do real-time ray tracing, ambient occlusion, dust particle, internal subscattering in real time. That would be okay. So what effect that'll have on compositing? It's just another tool. You still need a compositor. Somebody's got to twiddle the knobs.
Yeah.
Yeah.
Excellent.
May I jump in briefly, super
Yeah,
briefly?
sure.
I promise.
Yeah.
Last one.
Okay.
Because our school is almost finishing for us. So you are keeping up with the technologies and techniques for almost 40, 50 years now. So can you suggest us some place where we can keep studying, keep learning stuff? I know there is an amazing place called FX Ecademy that is very, very good, but someplace else.
My website does not specialize in the latest and greatest technology like alembic geometry and light field cinematography. If you want to stay abreast of what's going on, then what you want to do is look for the white papers coming out of the universities. That's where it all starts. From there, if it's going to grow legs, then a corporation will pick it up and try to productize it. But it all starts in the universities with the white papers.
Are you a fan of the regional exhibitions and shows like SIGGRAPH and NAB and Broadcast Asia and those sort of things? Are they useful?
Yes. Of course, saying hello to old friends, of course. But but that's where a really good question, John. It's in those trade shows that you get to see the productized version of the latest tech. Okay, you walk through the trade show and you can see the evolution. I remember the last NAB show I went to, everything was cloud servers. Everything is streaming. Everything that, we don't have any boxes now to do anything. It's all streaming virtual and in real time and in the cloud, and high bandwidth HIPAA pipes and huge performance in all this. It's all in software now. Everything's in software. So you're seeing all the virtualization of everything and the performance increase and the quality kick up. Right now, HD TV, 1928 by 1080, you got 2 million pixels. Well, when we go to UHD TV, that's 4 million pixels. That's 400% more pixels, 400% more disk storage, more bandwidth required to transfer. No problem, we'll do that. So no, the trade shows, the SIGGRAPHs. Now SIGGRAPH is more educational, collegiate. NAB show is more industrial, commercial. So at SIGGRAPH, you'll see artsy fartsy shows of the kids doing their flying, floating things. At the NAB, you will see a product made by a corporation that you can purchase. Okay, so the two very different spins, but they're both very valuable.
Excellent. Very good. And
although, to be honest with you, the last couple of NAB shows have been disappointing for me. Compositing, Foundry no longer does they used to do the NAB show, had a huge booth at NAB. Yeah. I used to do booth duty for them. I would give talks and presentations at the Foundry booth. They no longer do a booth because the NAB show has ceased to be a venue for this kind of a thing. Maya's not there. Blackmagic is there because they sell silicon
boxes. Yeah.
Yeah. In fact, they have a half an acre as their booth. Blackmagic is really something. Really impressive.
They are. It's amazing, isn't it? Have you looked at Fusion recently?
Yes. No. Fusion is good. Fusion is great. And if you know how, you can work in linear in Fusion. Okay, it's not native to it. You have to kind of twist it but and it's very great in the way. One way that Fusion is much better than Nuke in two ways actually. One, Fusion comes more with canned routines for you that already do stuff. Okay, with Nuke lays the tools on the table. You put them together. You make it. Okay, I remember I was doing Fusion to Nuke transition training in India once, and the Fusion guy said, "Well, now Fusion, I've got a fog node. I can do fog. See? Do you have fog in Nuke?" And I said, "Well, no, but give me a minute. 5 nodes later, I had a 3D fog, a volumetric fog that we could dial in, okay? So that's how one-way Fusion is superior to Nuke, is it has more canned goodies, we might say. The second way is Fusion does a really good job that the 3D preview you're seeing looks very much like your 2D render. Nuke falls down in this area, okay? The 3D, in the 3D world, the 3D preview does not look really very good compared to the CG render. But don't run out and start taking all those Fusion classes. Because even though Fusion is free, the non-commercial version, what you're not taking into account is the studio inertia. Visual Effects Studio inertia. They've been using Nuke for a decade. They have built huge infrastructure around it. The entire pipeline is based on Nuke. You don't just pull out Nuke and drop in Fusion. No, you have to completely rebuild the entire pipeline, all the tools, the file formats, the communication protocols, everything has to be completely rewritten to switch over to Fusion. Nuke has too much critical mass for that to happen.
Excellent. Great.
I'm a real nuker.
We can tell.
I love Nuke. I think it's so smart.
Yeah, I'd say it's all, yes, I mean, it's very, very much embedded in a lot of places now, isn't it?
Oh yeah, it's totally baked into all the big shops.
Yeah.
By the way, Boris FX has retained me to do to produce a video for them for Silhouette Paint.
Oh yeah. Mm-hmm.
It's a plugin, an OFX plugin for Nuke, and man, is it hot!
Oh yeah, it's the one that Frame Store uses in London a lot. Or they used to. They were using it a lot. I don't know if they still do, but
oh, yeah.
we didn't get a chance to use it, unfortunately, because I don't know. There was a number of reasons, but we were considering teaching it for a while.
You know, I would do at least the Silhouette.
We do, yeah.
Okay, because it's a plugin for Nuke, and Silhouette Paint is just brilliant. I mean, the guys really did a good implement, the whole workflow thing. Now, and as I was going through it, learning it, I'm going to be producing a 15-minute video for them. The thrust of it is, this is what Steve Wright thinks of Silhouette Paint. Okay, Steve thinks it's wonderful. But but the thing about it that was so impressive is its speed and its quality, high dynamic range, 32-bit float. I mean, all the smart stuff. Okay, and it just plugs right into Nuke, and it runs perfectly. It's really sweet. As I was going through Silhouette, I was saying, okay, you could track something, reverse it, stabilize the frame, and paint on the stabilized frame, and then unreverse it. Well, I could do that in Nuke. Yeah, 5 minutes later with 6 nodes. Okay, but with Silhouette, click, go, paint, next. Okay, it's all built in, baked in. The workflow is just brilliantly thought out. So productivity, speed, quality.
That's great, because we have this already, so that's really good to know.
Yeah,
because we love Boris. He's great.
Oh, do you know Boris?
He came to the school. Yeah.
Oh, nice. No, I've never met Boris. I know a couple of the engineers and the sales guy, the marketing guys, Shane and Marco Polio, but not Boris himself. I don't think I've ever met him.
Well, Marie, when he was asked over, because I used to work with Marie, and when she introduced us to him when he came over and he came to the school, and they've been very generous in helping us, enable us to use all their tools. So they're used quite extensively around the school in the editing department and in our department.
Wonderful.
So we have Silhouette.
Great. Well, now Silhouette's original claim to fame was their rotoscoping tools.
Yeah.
Very powerful. Then they added Silhouette Paint. This is just the paint. Okay, because Nuke's paint, it's a vector-based paint, and it can get heavy. Okay, but this is sweet. Silhouette does not get heavy ever. They've got a completely different novel architecture.
That's really good to know.
Yeah,
Thank you.
I'm having a ball. This Silhouette Paint is really a hoot.
You got to find something, haven't you?
Something new to chew on.
Something
Well,
new,
no,
exactly.
I love the new Nuke 12. They come the Edge Extend. You guys been playing with the Edge Extend?
Yeah.
Oh man, that is hot.
Today. The first years again should be shouting out. We've used it today on a broom handle.
Well, there you go, on a broom handle. I've actually found a dozen uses for it. You know, beyond extending edges for my CG comps. It's a hell of a replacement for the IBK color.
It's basically copying a gizmo that was on Wikipedia since like day one. So yeah, it works pretty good, I feel like.
Well, except it's written in C++, plus it's got a number of features to prevent it from introducing the artifacts that you saw before. So it's a smartened up, speeded up, heavier version. I mean, I've done the blur unpremultiplied gag, and I thought I was really clever. But this thing is just, really cool. You should try using it to make a clean plate for IBK.
We'll do that, Steve. Thank you.
Yep.
Yeah.
How many times have you tried to take IBK color and you couldn't really get everything?
This time, because of COVID, we would normally have done some keying kind of in this, first module, but we've taken it out and we're going to, I think,
doing it in September,
we're doing it. So all that good stuff, all the fun the guys have got, the first year guys have got to come. So so in a way, what you'd given us there with some more of the theory was, was a really nice sort of recap and firms up, so that the guys hopefully know that I'm not talking out my backside. Literally does come from you, the guy that wrote the book. So because we just really, it couldn't have been better timed, because we're just coming into all of that unpremult CG layers, type of stuff. But the IBK, that's a nice idea with the Edge Extend, but we will come to that in September. So
do we have time for a quick look at it?
We have as much time as you have, Steve. I mean, we're not going anywhere. We're all in lockdown.
Okay, sweet. Because
it really is up to you. If you've got time, then that's great.
I prepared a hell of a lot of stuff here. Okay, and I have only touched on a tiny fraction of it. Click share. You guys got it?
Yes.
Yay. Okay. Well, here's the issue. With IBK color, you're trying to make a clean plate that represents the background screen without the character. And sometimes you get into little shards that you can't quite get, okay? And what happens there is, you see the loss in my little dark feathers here? They coincide precisely with this residual. This residual is being subtracted from my character. So it leaves those pieces. Okay, that's why I'm losing my feather detail, right? Okay, well, since if it's a held frame, which an awful lot of these are a held frame, I can do a paint assist. Okay, do a paint assist. And, well, looky here, compared to the original, look at that. Okay. You might also use Edge Extend. Okay. Now, a couple of ways we can do that. I took my green screen, I just did a roto, and I inverted the alpha channel in my roto so that I could do a Premultiply to put a big black hole in the middle of my green screen, like so. Get Mr. Edge Extend. The brilliant thing about Edge Extend is, as you know, the green screen has variable gradient of color all over it. So this area here is being pulled in, and this area over here is being pulled in. So it's preserving the local color. That's the brilliant thing about Mr. Edge Extend. I used that compared again to the original one with just the IBK color. And this is Mr. Edge Extend. Okay, so I got much more retained detail. You can use a keyer, okay? Primat or key light, doesn't matter. The principle is the same. We're going to take the alpha channel, garbage mat it. I couldn't, neither key light nor Primat would get me those little fine hairs, those little dark feathers. So I wound up running a side thing to create my own little thing and then merge that with those two keys. The beautiful thing about what we're doing here is we really don't care about edge quality. We're trying to punch a hole in the green screen. Okay, so a little softening, a little contrast. Copy that in behind my green screen, invert the alpha channel, clamp, be sure to clamp so that you don't get some runaway code values. And then that's just a high con. I just used a grade node to make a high con version of the alpha channel. A little bit of an erode, and then there's my Premultiply to punch my big hole. So using keyers, you can punch your black hole and then use Mr. Edge Extend. Okay, and now I'm also getting excellent. Look at the retained detail here. Okay, so think beyond the IBK color node. I actually put together quite a bit of material which we didn't cover. Do you want to keep playing?
Same time next week.
Oh. How many folks have we still got, John?
Everybody's still. Nobody's gone.
Oh.
They will have a couple more who joined us actually. It really is up to you, Steve. I mean, it's past 8 o'clock. It's been 2 hours of your time. Obviously, we're very grateful.
Oh, well, I did.
If there's anything else you'd like to cover, carry on. Otherwise, we'll call it a day.
Oh, because I prepared a hell of a lot of material. Perhaps the most fruitful thing we might do is look at the tips and tricks. Well, let's do tips and tricks because in a few minutes we can hit a bunch of stuff. Okay.
That'd be great. And then maybe after that we'll wrap it up, shall we?
Sure. Y'all use light wrap and edge blur, right? Everybody nod yes. Okay. I just want to make sure that everybody knew that you do light wrap first and edge blur second. Furthermore, I like to do the edge blur after the comp, because see, I've got my alpha channel here, right? So the edge blur, here's why I'm doing this. If you run edge blur on the premultiplied image, okay, on this guy, what you're doing, frankly, is you're just blurring the edges. But when you do it afterwards, what's happening is the blur operation is going across this edge and it's mixing the pixels back and forth between the background and the foreground, and that's a more natural look. So I recommend edge blur after comp. Okay, a key out blur. Okay, so here's what this is about. I got myself a nice alpha channel. I want to run a blur on it, but as you know, the blur also moves the white point back. Sometimes you don't want that. Sometimes you want to blur it, out only. So if you will follow the blur with a grade node set for a white point of 0.5, and this is critical, turn on your white clamp. Because if you don't, you're going to get code values 2.0 here in the center. Now, what you get is a blur that only goes out. It does not drag the white point in. Okay. White point of 0.5, white clamp on. Very important. Super fine edge dilation and erode. We have Nuke, we have 4 lovely dilators and eroderators here, okay? But tragically, they all work in essentially 1 pixel increments. Even if you slide them to a 0.5, if you look closely, you'll be seeing a rolling cross dissolve. They're actually jumping in integer amounts. So what I like to do is I like to apply a blur to something. There's my blur. and then apply a grade node to that. Okay, so a blur followed by a grade node to do super fine edge tweaking. Okay, so I can increase the blur and or decrease the, see that? Okay, if I give it a larger blur, it's going to have more of a, and of course, if I do the blur out, it controls it, it only goes out. But so by having a blur, this has a blur of 2. If I make that a blur of 3, boom. Okay, but a small blur and then throw a gamma on the alpha channel. This is on the alpha channel. You have this incredibly fine control over your edge characteristics. Sculpting, a related concept is to sculpt the edges with a LUT, with a lookup table. Again, you know, you do your blur, but this time throwing a LUT on it. And, you know, sometimes I get into some interesting games where, you know, if I wanted to, let me make sure I'm looking at this guy. Okay, so if I want to, I can see if I'm pulling up on this, I'm putting the core out. If I pull back on this, I'm having the outside edge come in. I can feather the outside, but leave the core hard. Okay, so you get all this finesse and control by using a color curve or a LUT. And of course, our new edge extend node. I love this puppy. This is just wonderful stuff. I'll put you back over here. This particular shot has, this is a 35mm film shot. 35mm film has a problem called red spread. When it shoots blue screens and green screens, the red channel creeps out and causes anomalies like this. In fact, Kodak developed, you guys don't care about film anymore, do you? You guys do film?
Yeah, we do. We're still doing film, yeah.
Okay, because this is...
I was wondering if anybody had any 16mm questions, because there's a...
Oh.
Hints and tips for 16mm would be lovely.
Well, yeah, switch to 35. Yeah, when I was at CineSite, I worked with the film engineers and evaluated new film stocks for them. And this is the SFX 200, specifically made for this. It's made for shooting green screens and blue screens, okay? But this is not the SFX 200. So when this is keyed, I got this hideous edge and use the edge extend node to recolor that edge. And of course, y'all know about that. So just wanted to point that out. Here's a mind blower. The old tracking marker overlap. You know, how do we cope with this? Let me jump to a frame. Okay, the problem being that I can't key on this, and so what they wind up doing is painting these out. Don't paint. Use the IBK keyer. Now, this is a clean plate. This is an actual clean plate. I had them actually shoot the psych with no talent. So I took 8 frames and averaged them together. Remember that as long as it's a locked off camera, you can by hook or by crook, you can make your own clean plates, okay? Cutting and pasting several, whatever tricks you want to use. So this is 8 frames averaged together to make one clean plate. You feed, this is a real clean plate. Feed that to the IBK gizmo and watch the magic happen. Another one behind this guy's head here. Okay, Oh, this is a good one. The flying hair. See that? I love the IBK keyer. So by giving the IBK keyer a true, accurate, clean plate, your troubles are over. A post despill. Now, a lot of people, they composite inside the keyer, okay? And the keyer, maybe it doesn't do a totally bitchin' job, but spill suppression, but using the hue correct node, do a post spill suppression on the comp and clean up those last remaining scraps of spill. Okay. Pre-processing the green screen. Huge issue, but you got to be careful that you don't carry this too far. You can't just crank up the saturation on the greens on the plate, because when you do, you shift the color channels, okay, and you start hardening your edges. In fact, virtually everything you do in the real world hardens the edges of your key and loses hair detail. I don't know, it's just something about the process, okay. So what this is about is pre-processing the green screen. I'm going to turn off my fix. So I'm keying. Now this yellow, as you know, yellow on a green screen is problematic because it's a high green component and the keyer loves it. Ta-da! Okay. So, you know, we'll throw on our garbage mat here, slide it back under our despilled plate. So now we have, this is our key, boo rudo, okay? We perform our pre-multiply, we do our comp. This is a lovely test pattern that I would heartily recommend for checking your keys for reasons that are now all too obvious. Okay, it's just a noise node. I actually learned this from the guy that, the IBK keyer. The foundry wanted a video made of the IBK because nobody understood it, nobody could use it. So they sent me to Digital Domain and I sat for 1 hour. I had 1 hour with the guy that invented the IBK keyer. And I came with a whole bag full of stuff for him and I just had him key one thing after another and asked him a bunch of questions and to produce, and I produced the video that the foundry now has for the IBK keyer, okay? And this, something I learned from him is this is a way to stress your comp to see, you know, how you're doing, okay? And, you know, you just take a noise node and scale it the width of 10 so you get horizontal stripes and then animate it vertically in Y so that it will bounce around like this. And that gives you a lovely view of your key, okay? Now, to return to the issue at hand, the problem with my key is that key light couldn't get past the yellow shirt. So what I did was I used a hue correct node to suck out some of the green. Remember, I'm not using this in my comp. I'm using this as a source for the key. So I sucked out the offending color. And now Mr. Key Light looks like this instead of that. Okay, and it had virtually no effect on any other part of the picture because the hue keyer, the hue correct node is, you know, a very precise surgical thing. And made that, turned it from this into that. And then the finished composite now looks like this compared to before. Okay, so pre-processing the green screen to sweeten it up for the keyer. A very large topic, and what will sweeten it differs from shot to shot, okay? But something to think about for every one of your green screens is how can I make this thing so that the keyer loves it more. Okay.
That's amazing.
Oh.
Yeah, it
Thank
was.
you.
Thank you very much.
I appreciate that.
Superb, yeah. Great. Well, gosh, it's 8:20. You've been on for ages.
I made a lot of stuff, okay? You know.
It's fantastic.
I spent too much time on me, I think.
Well, we'd love to do another session with you at some point. Obviously, that would be great. It'd be fantastic. It's been really, really interesting and great to have you. And
well, thank you.
To hear about everything you've said has been riveting, and it just underlines a lot of things that we do here. And it's great to hear you speak. So I really, really appreciate your time. Thank you, Steve.
My pleasure, John.
Now that we've made contact, it would be, if you are in the UK, you must come and see us. Once we're back at the school.
Yes. Once you're there, right?
once I'm not at home and I can actually go to work.
Very good. I'd love to swing by and check out your digs.
Oh, it'd be great. We'd love to show you what we're doing as well. It's been we've been around for quite a while now, and it's great that we've made this contact. It's really truly appreciated. Thank you.
All right. Well, nice chatting with all of you. Thanks for the questions, by the way. Good questions.
Excellent. And
thank you very much for staying so long with us.
Yes.
Oh, my pleasure.
Yeah,
I prepped all this stuff.
Let's see if we can do another one at some point in the future. That'd be wonderful.
Sounds good.
Thank you very much, Steve. Take care.
Later.
Thank you.
Thank you. Bye.
Thank you, Steve. Bye. Bye.
Happy trails to you until we meet again. Happy trails to you. Keep smiling until then. Who cares about the clouds if we're together?
Just sing a song and bring the sunny weather.